Doctori, tutto a posto. Welcome back to a new episode of Sane C++ Libraries. That is a set of C++ platform abstraction libraries for macOS, Windows, and Linux that focuses on fast compile times, being bloat-free, simple and readable, and easy to integrate with no use of the C++ standard library and no use of exceptions and other party dependencies. We use OS APIs. This is the list of the libraries included. You can go and check it out on GitHub at this address, and you can just have fun. To build it, you can just add a single file to your existing project, and you're good to go. You may need to link a couple of system dependencies, which probably are already being linked by your projects. And you can get in touch on Discord, on Blue Sky, and if you really, really want, on Twitter. I prefer to call it like this. In Mastodon, or of course GitHub discussions. That being said, what are we going to do? The last time we have been working on this new thing that is the async streams, which are our version of Node.js streams, which is a very powerful state machine abstraction to do asynchronous I/O operations, handling back pressure, which means like pausing readable streams and resuming them when there is now again space and there is available buffers to continue doing whatever I/O operation was being done. We are trying to keep it within some constraints, design constraints, which means no allocation, no object mode. We like to have a more fixed data layout for these pipelines, and we don't support bot modes that are supported on Node.js. I think these are details not many will be interested in. So far we have readable streams, we have writable streams, but we don't have, so we can read from sources like from a file, we can write to a destination, so we can write to a socket or another file or any destination, any async destination, but we don't have a way to transform data. Like, what is a transformation? Well, you can imagine like compressing a file or doing some crypto or whatever, cryptography, of course, or anything like that. So we are going to address that. So let's try to add transform stream to async streams. Where do we try to put this? Well, after the writable streams could be a good start. So I'm going to create a struct AsyncTransformStream. And we can have this struct derived from, I guess, async readable stream and async writable stream, right? This is good. So now this is, we are not using any virtual function here. So this is just basically composition, more or less. We may need just to prefix fields that are named in a similar way with readable stream or writable stream, but I guess that's all right. I think we want to have a constructor because we will need to at least connect the read callback and make it empty. Yes, because we don't need reading here. We will be just receiving write events on the writable side and pushing the transformed events on the readable side. So something like, yeah, let me try to create it here. Maybe before the pipeline. AsyncTransformStream. 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 So I'm going to take async readable stream read, async read, and I can bind, does this take like a buffer ID? I don't remember. Let's try. And we're just going to return result true. No meshing function, okay. Oh, it does not take buffer ID. That's all right. Good. Can we create like a join, because each one of this readable and writable stream does have an init, because we need to specify the buffers pool and the request. So maybe let's create a common init that has a buffers pool and a span of requests. Of course, we will need both the readable requests and I think also the writable one, because in the writable stream, we have another init method that has, again, the buffer pool and the requests. So what are these requests? These are basically the queue that both readable and writable side. So this is writable request, and this is readable or read requests. These are the queues that on both sides are needed to keep the list of buffers that have not been written yet. For example, on the writable side, and on the readable side, that's basically the analogous concept. We are pushing all the data to read into this queue before delivering it. So let's call async readable stream init with the buffers pool and the readable requests. And we can try this. Let's do the same for the writable side with the writable requests. And we can say that it's good if we get so far. All right. So now we have, oh, this is technically not even a transform stream. It's more of a duplex stream. And I suspect we may want to rename this at some point. But for now, in the transform stream, we'll probably need to derive from the duplex stream, because Node.js has this distinction. Duplex stream is just, readable and writable stream. But when you make it so that the output of the stream is connected or derived from the input, then it's a transform stream. It's like a special type of duplex stream. But we will not be going that far today, so let's just keep it calling AsyncTransformStream. Now, I want to add, so we have our pipeline object that has source. So we read from somewhere and then we write to a number of destinations, which are called sinks. Now we want to have like another span, AsyncTransformStream, that we can say transforms. And I guess we can add the span of transforms here. AsyncTransformStream. Now, let's go to the pipe method and let's implement this other guy. Or maybe even better, let's make this the new default. So the pipe version with the AsyncTransformStreams. And this one will just return pipe async source, no transforms, async sync. So for the case where we don't have any transform. So now we can save the transform. Transforms are our async transforms, right? Out of line definition. No, this is good. Check buffers pool. This is the function that checks we always have the same buffer pool. Now we need to do the same for all of our transforms, because otherwise the entire abstraction will not work. All of the resume operations, they work under the assumption that we are sharing the same buffer pool. So I need to say transform get buffers pool if this is different from this buffers. Then we need to return an error. Of course, this get buffers pool is found in multiple base classes because we need to check it both for the readable stream side and the writable stream side. course, we need to compare the addresses. Okay. So let's make it also for async writable stream. So this looks good. Now, what else do we need to do? I definitely need to chain all of the transforms from the sources. Here it was pretty simple because we were just connecting the readable and to a method, this dispatch to pipes, and dispatch to pipes was just looping all of the things and writing to all of them. So now we need some sort of chain transforms. Yes. And the readable will not necessarily be the source anymore, but it can be any of the transforms. So the last transform in a row, and maybe this is not clear, so let me specify. This works like you have a source, the transforms are applied one after each other. So there's like a last transform that is also readable, so it's a source of data. And we want to take that as our readable that we are going to dispatch to the pipes and do the same as we were doing for the regular async pipeline case. So I would like to pass the readable here, and yes, let me implement something just down below here. Chain transforms, async readable stream. Yeah, let's return our reference. So that's our first readable, the root readable, and we need to output the last one. We return result true. And we need to declare this, of course, in the header. Let's say chain transforms. Okay. Of course, this needs to be SC tried. Now, how do we do that? I need to loop all of the all of the transforms, async transform stream transform, and this is, that's the easy part. Now I basically need to do the same that I'm doing here. So I definitely need to chain the readable end event of the previous readable. So every time like a readable in this pipeline is ending, I need to call the write of the next writable in chain, right? So I need to do readable event and add listener. I need to do it. What's my writable here? I need the writable stream, and I need to call writable stream and on a writable. This is my writable. Async writable stream. Writable. My writable is my transform, right? Okay. Too many arguments. Oh yeah, here we need the additional parentheses because we have the template arguments. And this is basically the template arguments here are breaking the macro invocation. Now my next readable becomes my transform, because my transform is both a writable and a readable. So when the writable side will end, we are terminating also the readable side, which of the next one, which makes sense, right? Please. This should make sense because I've been thinking about this already before starting, and I hope this is right. What do I need to do? I need to connect the error. So now I need to do readable and event error, but I have two of them. So I need async readable stream event error. I want to connect it to here. Basically, I'm chaining all of the errors such that they will get emitted as errors on the pipeline itself. So I'm just going to do emit error on the readable. No matching member function. What am I doing wrong? What's the signature of this event error? Event error. It's just it's emitting a result. That should be good. Oh, I should do it on the transform, maybe. Transform. No matching member function. Let's see what's going wrong. No conversion from async readable stream to async pipeline for first argument. Oh. Yes. Now we are talking. And the same for writable stream. Maybe I should be returning like an error message that is specific to, you know, this error that if any of these event listeners are reaching the number of maximum listeners, I should probably return a readable error other than just failing in the void with no specific explanation, but I guess that's fine for now. So we have connected the end events, the error events on both sides. So the readable side of the previous, it's going to end the next, and the next readable becomes the current transform, which makes sense. So we have like a readable, transform 0, transform 1, and so on until we reach all of the things. Right? It's something like that. But we still need to connect the data event, right? The same way we are connecting it here. And the data event is on the readable. So readable event data. The event data needs to add listener. No, here we need a lambda, right? How do we dispatch this? We need to use, there was a function. Yeah, async writable. This is completely parametric. We can use this one. Yeah, we still need to do this. Block when closing when there are in-flight writes. But for now, we need to be able calling this async writable, which is a funny name. Probably this deserves a rename. So how do I do that? I need to create a lambda async buffer spool ID, buffer ID. Of course, I need to grab pointer to this and async async writable buffer ID. Yeah, sometimes I'm using this just to help the intelligence. And what's my writable? My writable is exactly my writable stream. Writable, so it's the transform stream, the writable side of the transform stream. Does this work? Expected. Oh, this needs like an, yeah, let's do like auto lambda equals this, and then add listener lambda. You like it? No. Oh, there's a double buffer ID. No. I think buffer view. I'm just so bad at this. Okay. Yeah, maybe we need to move this into like a separate function if we want to be able to unregister this, which is something I would like to do, because I've been adding like a method to do that. Yeah, remove all listeners bound to something, and this will not work when I have a lambda. So I need to unregister the lambda with the other method, which is the remove listener with the func overload. But if this is in the middle of the loop, I don't have a reference to the lambda anymore. So I need to make this into some function outside, but I will do it later. Now, this should be good. What else do we need? I think the only other, so when we leave now the readable, the last readable will be the last transform, the last readable side of the last transform. And that will just work as before. We'll dispatch to the sinks. It will go to the end pipes, which is going to end all of the sinks. And it's going to emit error when needed. This looks correct to me, at least. I don't even know if I still need this one. Maybe yes. I don't know. Now we have started with the I don't know thing. So I guess that's going good. It has been bringing us very far so far. What do I need to do? Do I need to just start all of the transforms? Probably yes. So I'm going to loop all of the transforms and just say transform start. Yeah, this looks reasonable. How much time do we have? Yes, 22 minutes. Not do we have much time? Is this video already, how long have we been discussing these few lines of code? I'm not sure if I need to do something on the resume. Yes, after write. So when we receive a write, as any of the transform streams may have been paused, I need to resume them, or I would try to do that, but on the readable and on the writable side. So I have transform, resume, reading, and resume writing. Because after writing, it's the condition where we always may have been, finishing to write something. So the buffer related to this something is now free, and we can try to resume anything that was paused. That's why we have all of the resumes here. Because the entire design for the system is we pause things when we cannot allocate, and when we finish writing something, we try to resume, because we may have memory now and we can try again. And, if you are consistent with this, it works. I mean, it has been working so far. I hope it will scale to like something more complex, but I'm trying. And as I said, I don't know, so I'm just trying. This is something that looks good to me, at least. Now, so what we want to be doing now is creating an example stream. So I'm going to create this ZLib transform streams and the corresponding header, CPP file. Because I do have some ZLib things that I have been adding in previous commits. Maybe I'll show it very quickly. So what I have been doing is, first of all, creating this ZLib API, which is just taking the ZLib header and making it just a little bit more type safe, just a little bit more C++ style, of course, preserving the ABI so the error codes have the same values. So the API for ZLib is pretty stable and it's relatively safe to do that. I would not do that for maybe any random library, but for something that is so stable in its ABI, it's fine. Why am I doing that? I'm doing that because I want to dynamically load the library, so I need to have like function pointers to them. And as you can see in the inline file, I'm just loading the ZLib library. And the other reason is I don't want to require having ZLib header to build Sane C++ library. I would like just to be able to use ZLib if the DLL exists on the target machine, which is practically true for any macOS and also, I guess, most Linux distributions, if not all, unless you're using some very bare bones distribution that does not have ZLib. And even on Windows, I just discovered this, that you can, even if you don't find a ZLib1 DLL somewhere, you can use the CLR, so basically the .NET framework DLL named CLR compression. That is basically a compiled version of ZLib. It's not exporting all of the functions of ZLib, but it does export the ones we really, the most important ones, like the deflate end, inflate end, and the init too. So it's going to work for us. And this means that you can use the ZLib basically on the 3 major operating systems without even needing to deploy ZLib itself. If you really want to be using a specific version of it, then of course you can deploy just a compiled copy of ZLib with your program or install it from a package manager. And this is going to work because it's passing also the version, and ZLib does have some checks in order to make sure it's not crashing due to the ABI if it detects you are using like something that is not compatible with it. So this is going to be fine. I have created also a lightweight wrapper for it. It's just a wrapper to make it, just to avoid misusing the C interface. So I have this ZLibStream with the algorithms that you can use, which is the one called ZLib. There's the gzip one and the deflate. And you can init, you can process some data. You start with an input and you write to an output buffer, and then they get updated. So basically the input will get updated. So that's why you see it's passed by reference, and it will point to the unprocessed data, and the same for the output. And then you have the finalize, because once you have been pushing all of the input and you say, okay, now I just want to finalize my stream, which, some formats may compute some CRC or things like that, or push out the last block of compressed data. This may also require multiple iterations until the stream is actually ended, because you may be passing not enough memory for it, so it will consume all of the output, but you still need some more output to do that. So this does not necessarily mean that the stream is ended. And so you have this Boolean flag that is telling it if this is actually ended. If you have errors, you will get it into the results. So it's pretty standard stuff. So this is all non-allocating. That this way of designing APIs, it's not super handy, but this is how you design if you want to make, if you would like to give to the caller the power to decide when and if and how to allocate. Here you're just saying, give me some buffers of memory. I'm going to stay within these bounds you give me. This is made easy because this is just a wrapper. This is made easy because ZLib just provides that. So I'm not doing anything fancy. This is just a ZLib API mapped into this C++ interface to make it just slightly nicer, at least for my taste, which may not be everyone's taste. yeah, even when you're doing this ZLib or gzip, you need to remember you have to pass in like 16 plus max bits or minus max bits. How do you know that? Well, it's written in the ZLib documentation, but I guess for me at least, it's easier to just say, I want to use gzip. I don't want to remember to pass in, to inflate init to 16 plus max bits. So that's why I'm making like a wrapper. Now, let's make it, let's start this AsyncTransformStream. So this is ZLib, maybe sync transform stream, because for now we are going to make like a synchronous version because things are already very complicated, and I want to start easy. Internal ZLib API, no, ZLibStream. So namespace SC, and we can declare a ZLibStream stream, right? I also would like to include async streams, and this ZLib transform stream needs to be async transform stream. Well, it is not because it's synchronous, but the idea is with this interface, you can implement an async transform stream, but you can just forget about it and do everything in the single callback, do your processing, so it becomes a synchronous stream anyway. So, but we will create like an async version of this later on. How do I do that? I definitely need to register some stuff into the constructor. So let's make sure I can at least compile this. So include ZLib transform streams, right? Seed ZLib transform stream, sync ZLib transform streams. All right. Let's generate projects. This is the SC build, our own build system, which is simple, but we like it. Let's go back to Xcode, and we should be able to see our ZLib transform streams here. No new line at end of file. That's all right. What do I need to register here? I need to register the writable side. Async writable stream, async write. This becomes our transform function because this is where we are receiving a buffer. But you know what? I would like to always try binding it to a method. So I'm going to just call it transform async buffer view ID buffer. And I think we have the callback, which is the callback. Is this the right signature? I don't remember. Async write, yes, void async buffer view ID CB. So ZLib transform streams. What I have been using the plural form. Well, I guess we'll keep it like this. So when I have also the async version, I can keep the name plural. Nice. So async write. So the async write, if you remember, is the function. Basically, this is kind of like virtual inheritance, but instead of using virtual inheritance, we are using this std function like objects that are called function. And I prefer because I can use this also without necessarily doing like inheritance. So it's nicer in that regard. It does use a little bit more memory if you have many objects because these functions are going to use a little bit of memory for each instance of the object, but it's not a problem for considering how many of these we will be having. I'm still not 100% convinced that I will keep it like this. I may eventually switch this to like using virtual inheritance, but let's see. Now, I have my transform function. So my idea is I need to allocate like a new buffer, and I need to like push it to the readable side of this transform stream. So here, as I'm a transform stream, I'm both readable and writable. This is, I'm receiving a write, and I need to generate something that can be read by someone else. So I need to allocate a new buffer. So let's say if we have get buffers or pause, we don't have like a specific size we need. Let's say we have output buffer ID, output data, right? Otherwise, we need to do stuff. Async buffer view ID, output buffer ID. And we have a span of char, which is our output data. Now, I need to, before even doing that, I need to read this buffer that someone is asking me to compress with ZLib. So this is my input data. And I can get buffers pool, get, this IntelliSense is not working. Buffers pool, get data. Yeah, buffer ID and data. Get data. Buffer ID is buffer ID. I should probably call this buffer ID. And this is input data. And I'm going to try this. Member get buffers pool found in multiple base classes. So I need to say I want the sync readable stream side, which is going to be the same. If you remember, we are checking that it's the same. So I have the data, I have the output data. So the idea is that I can do stream process with the input data to the output data. And if this succeeds, well, I don't think I can. Yeah, well, because the problem here now, I cannot just early exit because I will lose the buffer. If result is true, then I need to check how much data I have been consuming. So let's say I'm checking how much data, what was the size of the output buffer before the process. So output before, it's output data size in bytes. And maybe, yes, we can do also the same for the input. So I can say consume and input bytes is input data size in bytes. So it's input before minus this one, and the same for the output. Output and output. Now, if I don't have an error, and if my consumed output bytes is bigger than 0, I can do async readable stream push, right? Which buffer ID? The output buffer ID, the new one that I just created. How many? I have just consuming output bytes, so yes, that should be it. And what about the input? So if I'm not consuming all of the inputs, that's like a problem, because I need to loop. Yeah, it means as this is like a ZLib transform stream, it can be even a decompression. So it will not just work if I take like a bigger buffer or buffer that is the same size as the input, because I may still need to require bigger output buffers in order to decompress everything. So while input data is empty, so while it's not empty, I need to loop. Yeah, this is reasonable. And this may also be failing. So before I have been able to empty the whole input buffer, I don't have an available buffer. So what do I do then? I need to, because I will lose this buffer ID, I need somehow to get called again with the same buffer. And one way that I have figured out to do so is to, actually, it's not something that I figured out. I figured out how Node.js is doing that. You have this async writable stream unshift. Actually, that was on the readable, but I have been taking the same concept. So this is a method that allows you to put, I mean, you can see how it's implemented. Let's go unshift. It's basically pushing to the front of the write queue whatever buffer with the callback that you're passing in. So we can say, okay, we have not finished with, with this buffer. I want to get called again. And yeah, and I'm going to just place it on top of the write queue. I'm wondering if here I'm paused, which should be fine. Not sure if I need to stop entirely the stream. Well, we will see it when we test it. But now I have a problem because I may have been processing already a little bit of input data. So I need to figure out how much input data do I have. So consumed input data is 0. Consumed input data, I can add my consumed input bytes. Of course, I can actually try this. But so if no, this is fine, because if all of the data has been consumed, I will leave this while, and I need to call async writable stream finished writing. So I can say, hey, I finished writing buffer ID with my callback. And I don't have any error, so I can say just result true. Actually, I think there was an issue where I need to move the callback. I had this same pattern elsewhere already. So let's do it in the same way. All right. Good. So the problem is now this is a writable stream, and we may get called by someone that is telling us, yay, you have to tell me if you can end. And that's where we need to do the finalization. So the finalization, it's going to be bound to this can-end writable, which is another mechanism that I have created. Allows basically to keep the writable in ending state until it has finished all pending data. So if you redefine this function, you can just return false to stay in ending state. And so you can finalize, whatever, in this case, whatever compression you are doing. So I guess I can say on and transform, or can and transform, maybe this. And so this becomes just a function that I can declare here. Bool can and transform. And I can declare it here. SC ZLib, async ZLibTransformStream. Yeah. So we will be doing something very similar also here. Returning false to stay in ending state. Can and transform. So what we need to call here, it's now, yeah, maybe here we need to emit error. Something like this. I need to call stream dot finalize. Finalize just needs an output and it has a stream ended. Right, so bool stream ended. And we also have a result, if result. So let's say we are ended. Let's build this step by step. So if we are ended, we can do a sync readable stream push and. So this is, and we can say return true because we can end. That's the case where we can end. We can end also if we have like an error. So we emit error res and return true. And with error and all good. We need the output data. So spawn char output data. We need to fill it. Async writable stream and error. Emit error. Now, if we get buffers or pause, output buffer ID, output data. And we have async writable, async buffer view ID, output buffer ID. Yeah, this will work. Actually, we can loop because, and when we have stream ended, this will leave this while loop either if we fail the allocation or if we are done and the stream is ended and we push end and we are all good, or if we have an error, of course, and so we just go in error. Maybe I should create an error state, but yeah, not now. Otherwise, I need to also here say output before. Maybe it's a char so that I can say consumed output bytes to be output before minus output data sizing in bytes. And if consumed output bytes is bigger than 0, we can emit the buffer with the new size, which is exactly consumed output bytes. Now, I think I'm forgetting. I need to, when getting buffer, I always need to unref the buffer because this is ref counted. So I need to do async readable stream get buffers pool unref buffer output buffer ID. And the same also after pushing, yes. Maybe even after emitting the error. Well, or before. I don't know. I need to figure out if, yeah, I definitely need to do it here because otherwise I will be leaking it, and I need to do it after pushing. So this is fine. And also here, I need to do it, well, either way, this is going to be done. So I need to make sure it's done in any case. This will be done in any case if ref is true, and will be done in any case if ref is false, which is good. Can I compile this? Yes. So this looks something we can start to try. So I'm continuing to modify our example. So let's include here the, well, how it's called, async streams, sync ZLib transform streams. And I need to basically modify the pipeline so that I have the transform streams. Where do I put them? I'm getting lost. Well, I'm getting lost because I'm looking at the wrong test. Writable socket stream. This is very verbose. I definitely need some work to reduce this, but just like many things, not now. Yeah, I can add it here. So this is the first pipeline and the second pipeline. Okay. So sync ZLibTransformStream. This is my compress stream. Compress stream, I will init with my buffers pool, which is buffers pool 1. I need some readable requests. So async readable stream request compress stream readable requests. Yeah, like this. And we need the writable. So these are basically the queue. The queues for the readable and the writable side. That's a, yeah, pretty low level interface. No, I mean, we can definitely create an API that it's less verbose and it's allocating these objects under the hood. But for now, I would like the API to be completely non-allocating. Then we can always bring back the allocation to bring in some ease of use. But for now, that's what I prefer. So after we init, we also need to take the stream and init the stream with the wanted algorithm, which is ZLibStream, I don't know, ZLib compress. So this is on the first pipeline where we are reading from a file and writing to a socket. Before doing that, we want to compress it with ZLib. So that's what this is doing. And And then I need to have AsyncTransformStream transform one. This is our compressed stream. And use it variable transforms one. Okay. And let's do the same for the decompress stream. So on the other side, if you remember in this sample, we are reading from a socket. So this sample is like reading from a file and writing to a socket, and then the socket is connected to another socket from which we are reading, and then writing again to a file, and then it's comparing that everything works. We are just placing a compressed transform stream in the middle of the first pipeline and a decompressed transform stream in the middle of the second pipeline. That's not the best API you can imagine. It's pretty verbose, but that's not how I envision people using it. That's a unit test. So let's just make sure that the not a unit test, it's a test. Let's make sure that the test is working fine. Transforms 2. Okay. Now I want to run just this one. Global console, let's say run. This is async request transform string test report and return 0. Let's see, are we even arriving here if we run the test? Okay. Let's run it. Of course, we have some errors. The first error that we have is all stream must use the same buffer pool, which is a reasonable request. So who is not using the same? So read socket stream, which it's using buffers pool 2. Oh yes, I'm passing in the compressed stream. So as you have seen, the this check that I've added, it's pretty important in the check buffers pool. We really want to make sure everything is on the same buffer pool, otherwise things will just not work. And let's try again. Async stream readable pause called in the wrong state. Interesting. Where am I calling it? During transform. Okay. So we are like resuming writing and we are arriving into our transform. So let's see, is this happening like first time? Like, no, so this is happening after a while. Okay, let's see, maybe we are going here into some of this unshift. That's where I was, yeah. Which state is it complaining that it's not the right state? Let's see. Wrong state. State is get buffer or pause. Reading, async reading, or anything like that. And instead, we are in pausing state. Why are we in pausing state? So we are in pausing state from previous. Do we need to put it into the stop state maybe? Can I even do that? Oh, I don't even have a function to do that. So let's say stop. I don't know. Is this the problem? So here we are in pausing state, but yeah, on a writable, we don't really want to, we need to pause the, yes. Okay, now I see what's the, because get buffer or pause is pausing the readable side, but we are not pausing the writable side. So, and there is no pause, there's just a stopped event because we don't have a difference. There's just like not writing and writing. So when it's not writing, it's stopped, and that's where we need to go. So when we unshift and we are paused on the readable side, we definitely want to be paused on the writable side. Otherwise, we'll be getting this transform. This is bad because we will be trying to get a buffer while we are in paused state on the readable side, which is not correct. So let's try to see if this is working. Not working yet. I'm starting to run out of ideas, but let's see if I can figure this out without needing to pause this video and spending like insane amount of time to figure out what's wrong. I don't think this makes any difference, and it does not. What am I doing wrong? Am I even arriving here in the can transform? Okay. Is this even arriving here? Oh, we are even arriving to the push end. Okay. Well, this is... So this is pipeline number 1. Is it pipeline 1? Yeah. Called in wrong state. Let's see which state. It's still this get buffer or pause that is complaining. So the stop has not really been making any difference. So why is this not? Any idea of what's going on? I don't have an idea. Get buffer or pause. Request new buffer or pause. Oh, wait a minute. This should be... You should not be calling the finish writing, because when you unshift, you cannot... I'm like unshifting the buffer, so putting it back on the queue, then saying, yeah, I just finished writing it. That's not probably correct. Let's see if this is... Okay, now we are stuck in like in an infinite loop. Okay. So we are processing the data, pushing. What's wrong here? Unwrap the buffer. Input data. So we are looping here forever. How much data we are consuming? Consumed input byte 67. Input before. So it's the same. Why? What am I doing wrong? Oh, wait a minute. Here, I'm tracking this consumed input data, but I need to slice the start of this buffer, right? Because when coming back here, I have already consumed this data, And so I should not start. So basically, when we go into the end shift, this is putting the buffer back in the queue. So we will get called again. And when we get called again, we have already consumed this much input data that, of course, I need to reset here. And this should make things better. Let's see. I don't know what to say. This is working. So yes, well, I'm really happy this is happening, and it was actually easier than I was thinking. Well, of course, there is a lot of work that I have done before to create this stream object that is doing all the work, and actually all the work is done by ZLib. It's not me, but yeah, it's cool. So here, again, let's recap, even if the video is quite long, but not longer than the usual. So what I have done is, I have these two pipelines that one is reading from a source file and writing to like a socket. I'm placing like a compress stream in the middle. So I'm like compressing the file. And on the receiving side, I'm receiving the compressed data that I'm like decompressing and writing to a file, and I'm checking like that the file is actually the content is what I think it should be, and it is. So this is kind of a small sync client if you want, or like Dropbox, like Poor's Man Dropbox. We can create like a Poor's Man Dropbox sample maybe at some point, but the fact that this is working is making me very happy. And yeah, I hope you enjoyed this video, and make sure to subscribe. Make sure to check out the GitHub project and write to the Discord if you have any question or any curiosity about what is being done here. I suspect that if I move something here, I will hit some edge case that will not be covered, but I want to end this video on a positive note. So I see green, my test works, it works. That's going to be good. And what can I say? See you next time with Sane C++ libraries. Bye.